Radial Engine Assembly Tutorial Part 3. Part 3 consists of radial engine assembly. Please pause and read this slide carefully. It is important that you have these settings in order to go on. The method used in this presentation is as follows. It is meant to streamline the assembly process for beginner and intermediate users.
Here we will be assembling one piston head and 4 piston rings. As seen in the video, open the piston head and piston ring part in CATIA. From start, go to Mechanical Design, Assembly Design Workbench, and align them horizontally. From the specification tree, drag each part to the assembly window. Be sure to drop the part where it says Product 1. Dragging one piston head and 4 piston rings into the assembly, maximize the assembly window. Using the manipulation button, drag the piston ring along any axis you prefer. By spreading out all the parts, it will become easy to keep track of the assembly. Here, the piston ring is moved along the piston pin axis. Now, having all the parts lined up, it's time to constrain each part. Having the constraint toolbar and Update All button, you are now ready to assemble piston head and piston ring. Choosing the coincidence constraint button, choose the axis of piston head and the axis of one of the piston ring. Next, select the bottom face of the gap in the piston head where the ring will be placed. While pressing the Control key, select the bottom face of the piston ring. Here, be sure to select the face, not the edge. Then, click on the Contact Constraint button in the Constraints toolbar. Click on Update All button and see the two parts come together. Doing the same for 3 more rings. Video will skip to the final ring for a review. Now, all 4 rings are constrained with the piston head. Looking to check any errors, the part looks fine. Next is articulated rod, upper and lower rod bush. Because the steps are same for upper and lower bushing, the lower bush will be only showed in this video. Select the Coincidence Constraint button and choose axis of the bushing and axis of the lower rod. Next, click the Offset Constraint button and select the top surface of the lower rod and circular surface of the bushing. Zoom in if you need to. The distance between the two planes is 2 mm. Click on the Update All button. The part's updated, but the bushing is sticking out from the rod. This is a problem. This means the distance between the two planes needs to be -2. Double-click on the green constraint and change the value to -2. Click Update All button to see if the parts are constrained properly.
Techniques before can be applied to the master rod and master rod bearing, as well as the piston pin and piston plug assemblies.
Next is assembly of piston head, piston pin, and articulated rod. Open each part in assembly window. Drag one articulated rod with upper and lower bushing, one piston head with 4 piston ring assembled, and 1 piston pin, and maximize the assembly window. Using the manipulation button, move each part to make it easier to constrain the each. Using the Coincidence Constraint button, constrain between the axis of a counterbore hole on the side of the piston head and upper articulated rod. Selecting the inside surface of the piston head and the outside surface of upper articulated rod while holding Ctrl key, click on the offset button. The distance is 4 mm. Click on Update All button and check the part. Now, constrain the piston head and the piston pin, doing the same step. The distance between the head of the piston pin and the counterbore surface is 0.5 mm. Click Update All button and check the part. Constraining at the piston pinhole is complete. Now, it is necessary to constrain the angle of the rod in the piston head. To show the example, the piston head will be rotated initially using the manipulation button. Selecting the flat surface of the rod and the bottom surface of the piston head while holding Ctrl key, click on the angle constraint button and enter 90 degrees. Click Update All button and the piston head and the rod should now be in perpendicular position.
The sub-assemblies we have just created will be placed inside another assembly. The main deciding factor of their positioning will be the angles of separation shown here. If need be, please pause and take note of the values shown and to where they correspond. Open a new product along with all the required parts and tile your windows either horizontally or vertically. Then proceed to drag and drop your sub-assemblies in a similar manner to the previous assemblies. When this is done, minimize all other windows and maximize the new product window. Once this is done, fit all to window, then move to the Manipulate button, which looks like a hand holding blocks, and move the parts with the same techniques as described in the earlier sections of this video. You must separate all of your parts in order to better plan and organize the assembly. Here we see how the piston head rods are being moved to a position that is similar to their final location. This is done so that when you choose the constraints, it will be both visually and logically easier to keep track of where you have been. As you can see, the positioning of the sub-assemblies can be very tedious, and after speeding up time, we can see our progress. This zoomed-in view demonstrates how the rods are to be connected to the master rod through the use of the coincidence constraint, which is choosing the central axes, and the contact constraint, which is choosing the inner surface of the master rod and selecting the top surface of the articulated rod, as shown. The link pin will be attached to the master rod with the same commands as shown for the articulated rod being connected to the master rod. Once again, speeding up time, we see how the main assembly has shaped up. As you can see, the constraints tree has just been opened. You can now see how the constraints have been ordered in terms of the master rod. This has been done by selecting the component and then choosing the master rod. This is essential for being organized as it helps other users of your assembly quickly follow the logic of your assembly. This also greatly aids in troubleshooting any errors you may have during assembly that may have been caused by incorrect placement of constraints. Here we see the final general shape is coming along, and we are now moving on to the angular constraints that we mentioned at the beginning of this video section. When choosing the surfaces to constrain, remember to choose them because they are perpendicular to the part shown, and are the inside faces that face each other as shown in the video. Then, once these two faces are chosen, move to the Angular Constraints button and key in the required values. Recalling the values mentioned earlier of 70 and 75 degrees, it is important to note that in this assembly it is not sufficient to simply key in these values. They need to be subtracted from 180 degrees as shown in order to achieve the correct positioning. This is because of the way we have chosen the surfaces. Repeating these steps 3 more times, we will have completed our angular constraining. As you can see in the video, the angular constraint has only been used 4 times. This is because as you're creating the 360-degree circle of these angles, the final set angle is automatically created due to your 4 previous constraints. Here is the final assembly of the Radial engine. Thank you for watching.